First thing we need to do is go through a few definitions to start us out. When I'm talking about imaginary numbers, that's when I squared equals -1, when you start seeing I in your problems. So since I squared is -1, that means I represents the square root of -1. So most of the time we see an I, and that is what makes it imaginary. It just represents the square root of a -1. Any number of the form a plus bi is called a complex number. A plus bi is what we call the standard form. In Algebra 2, we told you to write your answers that way, but if you didn't, we didn't necessarily take off. Now I will. So I want all of our answers to be written in a plus bi form, the real part plus the imaginary part. We will be breaking down these numbers in a few minutes and talking about them. A represents your real number part, B represents the imaginary part of your numbers. So we are going to start classifying complex numbers to begin with. A plus bi itself makes it complex, but then there are some special cases. A real number is one that doesn't have an imaginary part, so something like -6, +3. There's no I in it. Those are real numbers. A pure imaginary number doesn't have a real part, so it's like -2i. 5i. They only have the I term. Non-real complex is when you have both parts. -3 plus 4i. You have real and you have an imaginary. Alright, so first thing we're going to do is classify each of these numbers using all the terms that we can. So we might have more than one. If I give you 13i, how would I classify that? There's no real number, so it's pure imaginary. There is a second term that we can put with all of these. Actually, I didn't even ask. We could also call this complex, but I didn't even ask you to do that. I just asked you to do real, pure imaginary, or non-real complex. So you wouldn't have to. I may just put it out to the side like in parentheses if I asked this was also considered a complex number. Every number that I give you is complex. So people have a tendency to assume if I say the word complex that it has to have an I in it, and that is not true. When I say complex, it might have an I in it, but it doesn't have to. So if I said 5 plus I, how would you classify that? Has both parts, so that is non-real complex. Again, this is a complex number. If that was one of our choices, we would also include that. What would you call pi? That is a real number. And it is also considered complex. It doesn't have an I with it, but every number I give you is a complex number. Any questions there? Yes, ma'am. None of the ones we will look at. Everything we look at is a complex number.
Would you do it once to just write a complex if none of those were an option?
One of those will always be an option because the only ways I can give you the number is it could not have an I in it, which means it's real. It could have an I in it, which means it's pure imaginary, or it could have both, which means it's non-real complex. So you will always have one of those three terms.
Okay.
Other questions? talk about simplifying. If I ask you to reduce radicals that have a negative underneath, what we do is pull out the I. So if I say the square root of negative 5, you could think of that as the square root of 5 times the square root of negative 1. And we know the square root of negative 1 is I. You can write it as radical 5I. Just make sure the I is outside the radical. I think your Algebra 2 book usually put the I in front of the radical. Either way is fine with me. So far, so good? I'm going to put a few up here, and I want you guys to try to reduce them as much as you can. So I want you to do square root of negative 1. I need to make that smaller. The square root of negative 16. And let's do... Okay, reduce each of those for me. They're all the same. Square root of negative 1 is just an I. Square root of negative 16?
4.
Okay, square root of negative 8. This one you have to reduce. We know there's an I because of the negative. Now 8, what could you break it into?
2 and 4.
Square root of 4 is 2. We can't do the square root of 2, so it's 2I radical 2. Is that all right with everybody? I want to talk about multiplying here. You need to be a little bit careful. If you are going to multiply with radicals, you have to pull out the negative, so pull out the I, before you multiply those together. For instance, if I gave you this problem, square root of negative 9 times square root of negative 4. If you just multiply negative 4 times negative 9, you get the square root of 36, which is 6, right? But if I first broke these down, what is the square root of negative 4? What is the square root of negative 9? Okay. If I multiply those, 2 times 3 is 6, I times I is I squared. What is I squared equal to? Negative 1. That's just the definition. Usually when you square something, it becomes positive. That's why this is imaginary. It's the one thing that you square and it becomes negative. And this gives you negative 6. If you don't pull out those radicals, you will have the wrong sign on your final answer. So, sorry if you don't pull out the i's. So, pull out the I first, then multiply together.
So we can do anything with this 6?
No, I was just, this is wrong. That's not the correct answer. So I just wanted to show you, don't do it that way. Do it this way. All right. I'm going to do a couple, and then I want you guys to try a couple. So if I give you the square root of negative 7 times the square root of negative 7. I can't do the square root of 7, but what could you at least do here? Well, if you multiply it, it becomes a positive 49. So instead, what should I pull out? Take out your I. This would be I radical 7 times I radical 7. Okay, so now if we multiply, I times I is I squared, When you multiply radicals, you multiply the numbers underneath, so we get the square root of 7 times the square root of 7 is the square root of 49. I squared is square root of 49. So negative 1 times 7 is negative 7. B. Can we reduce either 6 or 10? No, so instead let's just start by taking out our I. So I times I, square root of 6 times 10. I squared is negative 1. Square root of 60, that is not a perfect square. Can it be broken down? We need a perfect square, so our perfect squares are like 4, 9, 16, 25. 4. Square root of 4 is 2. Can't do the square root of 15. So you get negative 2 radical 15. Let's look at C and D. So I threw in some division. If we wanted, we could take out the I first. We could even break these up a little bit more. I'm going to wait just a minute before I do that. If you take out those I's, what happens? Cancel, don't they? You have I's on top and bottom. Okay. You can't leave a radical on the denominator. So we could multiply top and bottom by radical 2 and simplify. But another trick I'm going to show you, if both the top and the bottom are under a radical, you could think of that as under one big radical. What is 20 divided by 2? So this is the square root of 10. Can you reduce the square root of 10? No, so that's our final answer. One more. Since both of these are under a radical, how could I write this?
Under 1.
What is negative 48 divided by 24? Okay, square root of negative 2, how can you simplify that? Perfect. Any questions for me? I'm going to put 4 up on what you guys do. So on the first one, you took an I out of each. Then you multiply and got I squared radical 169, so negative 13. Second one, take out your I. So you get I squared radical 24. 24 can be broken into a 4 and a 6, so you get negative 2 radical 6. Third one, you could make this one big radical. If you take out the i's first, that's great. If not, it doesn't really matter with division. And multiplication is the one where that absolutely has to be your first step. Negative 30 divided by negative 10 is positive 3. If you took out the i's, those dropped and you had 30 over 10, which is still radical 3. And D, you get the square root of negative 3 which would turn into I radical 3. Any issues with those? So next we're just going to get into operations. We're probably going to do addition, subtraction, maybe multiplication today. Hopefully we can get to that. Basically when we add and subtract, we're just combining like terms. When we multiply, we're going to FOIL like normal. So nothing too crazy here, except you're going to have i's in it. So if I gave you this problem, and I told you to add, you literally just add like terms. So 3 and negative 2 gives me 1. 5i plus 3i is 8i. This is where I'm going to be a stickler. I want a plus bi form. So if you wrote 8i plus 1, I'd probably take off a half point. On the test, I will say in the directions, write your answer in standard form. So always a plus bi, the real plus the imaginary. Is A okay with everybody? On B, what would I need to do?
Just show your negative.
Then you just combine like terms. So 6 plus negative 3, 4i plus negative 6i. So you get 3 minus 2i. Do we need more addition and subtraction examples? Let's talk about multiplication. We'll do a few of these and then we will probably be done for today. I'm going to kind of jump ahead. Let's go to this one. Right. So looking at this, if I told you to multiply, you're going to do the same thing you would do if there were x's in there, which is what? FOIL. So first we get 10 plus 35i plus 6i plus 21i squared. Okay, what do you do now?
Add your like terms. Can you
Wait, does it?
I squared.
Yeah, it's a negative.
So this is a 41i. Now, we know I squared is negative 1. So this is 21 times negative 1, so that's a negative 21. A plus bi form, so 10 plus negative 21 is negative 11 plus 41i. So I want standard form for each of your answers. So the one thing that you have to watch with the foiling is you will get an I squared and you do need to change that to negative 1. That's the only trick to it. Let's do one more for sure. So on this one, FOIL, so we get negative 10 minus 15i minus 16i minus 24i. Negative 15i and negative 16i would be negative 31i. Negative 24i squared is so negative 10 plus 24 would be 14 minus 31i. Do we need more multiplication? We are not done with this section. I still have to talk about dividing. and powers of I, so that will be the piece that we do tomorrow. There is one Math Excel assignment for this section. It's like 24 questions. You can probably do the first, I don't remember exactly, first 17 or so you know how to do most of them at this point. And you've got about 14 minutes right now if you want to get started on that. So the Math Excel, we'll finish the section tomorrow, so it will actually be due by the end of the day on Wednesday.